Welcome back, fellow shop rats. Today we are back in our machine shop series. We are working on our Cincinnati Lathe. Today we're going to be moving this unit out, doing some testing on it, getting it hooked up, getting it wired up, etc. Not in that order. My buddy Chris is here. He'll be joining me momentarily, and we're going to get after this. I'm Mike, and you're watching Mike Our Shop. There's a lot going to be happening here, but I did want to do a quick preamble to this episode and say it's always about spending the day here in the shop, whatever I'm working on. I tend to be pretty much of a shotgun. I'm on this, I'm on that, I'm on this, I'm on that, I'm on this. That works for me. I know it drives some people crazy, but I've been waiting for a long time to get this done. We are not going to be building the new controller for this. We're going to tap into the controller that we have for the mill today. To use it, we're going to have it wired up that way, and in the future we will get the new three-phase controller, 480 volt controller hooked up for this separately from that, so both machines can be run at once. Right now we'll only be able to run one at a time, which is fine. We spent some time coming up with a game plan, and the first thing we're going to do is move this out so Chris can test the motor, check all three phases of the motor, make sure that's working good. We know we have a bent motor plate. If that's simple to deal with, we'll deal with that today. If not, we'll make a plan. But we're going to move this out, do all the testing, and then we're going to do a little rearranging to pull the machine shop a little bit closer together. So we're going to move the lathe this way as far as we can and move our sheet metal brake and our pipe anvil somewhere else. Part of my thinking is that it will give us the ability to possibly put the Oakland right tight to the wall, because it's going to be tied up in here for a while as we pull the engine apart on that. So anyway, we'll just share progress with you as we make it. As we've mentioned before, when you're moving equipment of this size, get the proper equipment so you don't die to death. And having the proper toe jacks and equipment dollies and things like that, this stuff will kill you or cripple you, and so it's dangerous enough with the proper tools, but without the proper tools, it's.
Eventually, I'm probably going to make my own. These things aren't really that complicated, but I'd like to have my own set instead of having to borrow.
Right.
Because it seems like I do this more often than I recognize that I would have.
Yep. Well, it's almost if you have equipment this heavy, it's almost worth just having, because you never know when you're going to need to move something out to work on it or whatever. So.
And one of the other key things to remember is don't move it any farther than what you absolutely have to, and don't trust your fingers, your toes, your neck to the way this thing sits. Make sure you're never under the fall of it. Make sure you're always outside the shadow. You reach out and do this, and you don't climb under there and try to muscle it.
Yep.
Like right here, I'm going to make sure that that's blocked so I can remember how far in I can come with that.
I think we put the dollies right under the corners last time, if I remember right. I don't think we put them under the feet.
No, there isn't enough room there and not enough meat.
Right.
This is a plate that goes from here to here, and it's really only supported in this box. While that's particularly strong, your stresses would be here and here. So to come over here on the corner would be a nice solid place to put that dolly.
Yep. I think that's what we did last time on both sides. On that side, I think the feet are on the outside edge. But this, of course, this is the light end also. So, all right, we're going to get her set up, and then we'll be back. Does that give you enough room? A little more?
Just need room to get back behind there.
Let's just get her. I mean, it's rolling easy, so.
Well, this is about...
Whoop, whoop, whoop. Okay. Is that good? More?
Yeah, that's probably good. We can get around there.
Okay, so let's put the jack under just to keep it from rolling.
Can you hold that?
I got it, yep. Is that end rolling?
Yeah, this end's rolling. I'll hold it if you want to throw the jack on.
Okay, all right.
I think I'm holding it.
Did you tighten down the...
No.
Okay, where's the handle?
Handle's standing up there right on the back edge of it.
Oh.
There you go.
I got it. Okay, good.
That's good enough for now.
Yep.
And our wooden blocks Oh, they're right behind it. At least mine is.
Get those back under there for safety. Okay, looks good.
Just center them back on here, and we'll let it right back down on those blocks.
Do we want to just leave it there? Because we got to move it over in this way anyway.
Yeah, but we want it on the blocks for security so we can work on it.
Okay, that's fine. Yep.
Tug and pull and push.
Yep, true. Okay, so we'll get her back down and go from there. Cool. So here's what I know so far. This machine was functioning when it was taken out. So, Chris, you correct me when I'm wrong. I think the thing to do is to get it wired up. Whatever you need to do to test the motor.
Yeah. Now that's my thinking, is that the motor we can test separately from the rest of everything else. We just need to get it spinning.
Yep.
If we have to slack the motor and take the belt off or whatever, we can wire into the motor. Well, this is a family-oriented show, so I won't use the name for that I would normally use. We will disconnect it at this access point here.
Okay.
And wire into the motor directly. Then we can do voltage and current and make sure our phases are balanced and that everything either does or does not work.
Okay.
And then I was just noticing.
We knew the motor plate was bent.
Yeah. And you can see that it's over into here at the top. It should be in a line right down here. So the very bottom we're off by a fair bit, but this metal is not nearly as heavy as I thought it was. I think that's going to be a little bit easier than I was thinking to crab that back into position.
This bottom corner does nothing. It's just there as to hold the
this,
right.
yeah.
So my thinking is, if we, the metaller or the metal fabricator in me says, if we bend this here by applying force.
This shows it easier right here. Let me take this cover off, and you can come in right from the side and see that.
Yep.
There we go.
Yep. Okay, so there is a mount down here.
Yeah, and those are the adjustments. Those are the slide adjustments. There's several of them. There's 3 total, but
okay, and
this will be a lot easier to adjust than I was thinking.
And it's belt driven, so probably not losing a ton of power because the plate is bent.
But now, one thing to look at is that now this is probably okay, that's just on the surface.
Okay,
I was wondering if maybe that. Well, those things can be very aggressive. You get the right one that'll attack rubber, and it can eat that out.
Right.
But no, that seems to be all just surface.
Right.
Something biological that was on there that just started the mold. So these belts aren't in that bad a shape.
I think with your big monkey wrench on here, we'll be able to get that really close.
Yeah.
It doesn't have to be perfect, because I thought it was gear driven, and it's not. It's not gear driven until it gets up there.
Right.
So this doesn't have to be high holy within 3,000ths. It just needs to be in a ballpark that by eye it looks straight.
Well, the belts will allow for some degree of
exactly.
misalignment there, but the more misalignment, the more it's going to wear those belts.
Well, not just wearing the belts, but it's also potentially putting binding on the case, causing the motor to,
And this face right here, which is the end of the headstock, I think is our reference for when this thing is straight.
Okay.
So it's basically just get it crabbed back over and get it to set on here correctly, and then we should have no problem with the belts.
Okay.
But I note there's another little. That looks like a pump.
That's the pump. Yeah, I was wondering where the pump was. There's a pump motor on the other end, and there's a pump motor here. So they must have 2 lubrication points.
Well, there is a tray. There's a big tray underneath here that looks like it might be watertight. That might be it is. It's a cutting coolant pump.
Yes, I knew there was, but this pump here is for that. So I'm wondering what that pump is for.
Lubrication of the headstock.
Oh, gotcha.
That would be an oil pump, and that's a cutting fluid water
Gotcha. Okay.
pump.
Yep. Okay. So we're going to really want to clean that tray out good.
Yeah. Actually, the whole thing needs a job of cleaning and wire brushing, and all this crud and chips and cuttings can come out of here.
Same thing we did to that.
Yeah. But interestingly enough...
Oh, those are mine.
Oh, okay.
Yeah. You need any of those? I have about 50 of them.
Actually, I might take 1 or 2 of them. Okay. I use TNCs on some of my radio equipment from back in the day.
So I think we're ready to fire it up.
Okay. Connectors on. Everything looks good.
Okay.
There's the power cord. Okay. Yeah, little dip in the lights. That's a big transformer coming in
480 there. Transformer just kicked on. I heard the controller beep. Oh, that was the whatchamacallit on the mill.
Yeah,
DRO. Yep.
We run the DRO off of this? Okay.
Yeah, it's plugged into the 110 side. Okay.
Okay,
Don't
that's
forget to
on.
turn on the remote.
Oh, yeah, sorry. Remote. There we go. And run.
So it sounds like it powered up.
I work on these things every day. You'd think I'd remember that local remote switch.
Oh, I forget that once in a while myself. So.
Okay, hands clear.
Yep.
Now turn on the disconnect. Ooh. Yeah.
Humming?
Transformer of some sort.
That's probably the step-down transformer for the electric motor for the pump.
Yeah, well, that means we got power on it.
Yep.
Cool. So that's ready. This is on.
Okay, so there's a power switch here. That's probably for the pump, is my guess. Oh, that's for the motor controller. Should I turn that on?
Yeah, I would think so.
Is there anything, if this spins?
Let's make sure. Okay, headstock's free to move. Nothing is in the way. Let's make sure that this guy, I believe that's the neutral position.
I'm assuming this is our actual on and off here, and this is just probably for the pump, but it does say motor controller. Woo!
Oh, there's a load there.
We blew something. Okay. Put a fault into the controller.
We got an alarm. Output phase loss.
Huh.
Hang on.
We did the numbers. This shouldn't be drawing too much amperage, should it?
Well, we can take a look at that. But the fault is clear. We're still in remote. Okay, yeah, this has come back up now.
I'm kind of reluctant to turn it back on again. Output phase loss.
Okay, give this a second to actually come up to speed. There we go, that's 60 hertz output. I should probably change that timing so that thing comes up a little bit faster. That was like 15 seconds, so it's just a constant that determines how fast that comes up. Well, here, since we're here, rather than going great guns, let's do this in the regular manner of reading voltages and opening cabinets. And it'd be nice just to kick it on and have it run, but there's a possibility there may be an issue with that.
Well, and who knows? Maybe that's the pump motor and it's seized up, and it's not the drive motor for the thing. Because I still think these on the front are the controllers for the lathe. I don't know what that switch is up there for, so we'll have to figure that out.
Yeah. There could be a shorted motor or anything on here.
Okay, what do we got?
Well, this is the print that was in the back door of the thing, which is kind of nice. They left this in there. But a couple of observations. First of all, incoming three-phase power is here. These are the contactors that drive the spindle motor, and there's a set for forward and reverse. Then these run the coolant pump, which is what we were having a problem with. Now this goes directly off the 2M contactor, and where did I see that? 2M is right down here. That's indicated with water. This coming in brings in the contactor, overloads down here to turn it off if it needs it, but that brings in this. We have a 220 volt motor down there. With
on the coolant.
On the coolant.
Yep.
This says it's three-phase 480, which they've obviously modified this then. And that little transformer is probably what takes it there. And I thought we traced that wiring back so that the switch that we're calling in that is causing us to lose a phase on our power.
This transformer.
Right. So
this switch controls this transformer that runs the coolant motor down there. Yep.
Now, that may be bad. This thing we can call in without the switch on, so it's probably not the transformer. It's probably just something bumming that thing. It could be gummed up and crudted. I don't know.
That's my guess. This thing has been so long that motor is probably full of sludge.
Yeah. Now, there's a whole tank down there, too, that probably needs to be cleaned. And,
Yep.
And,
okay.
Oh, that'll be a mess to get that out of there.
So where we're at, go ahead.
So what I was thinking is that this switch coming on with this transformer trying to drive that gives us a phase loss.
Because it's pulling off of one phase
it's pulling off of one phase.
to make the
It's
220.
lagging that down.
Yep.
When we run this one, we get a phase under voltage. When we tried to run the big motor at first, we were getting I believe it was a phase under voltage loss, which is different than a phase loss.
Let me explain. That's coming from this controller here. It's a 480 volt three-phase controller, and that's giving us the error messages telling us what's going on.
Now, it's a very good possibility because that thing is taking 110 to 480 through a transformer. We probably would need heavier wiring in order to do that right. And it's probably just that this is such a load that it's causing the controller problems because there isn't really enough grunt feeding the back end of it.
Right.
But what we're going to try here is we've bypassed all of that. So all the contactors trying to pull in to this big load with that thing already up to speed is my guess as to what the problem that we're having. That'll be fixed in the next iteration of a controller for this by bypassing all of this, duplicating it with the drive, and then putting a small set of controls up front. So you can start forward and reverse so that this motor is always presented as a load on the controller, and it's not suddenly trying to grab this big load and spin it. It will wind up itself nice and easy. We can set our time constant short so it'll come up in, say, 3 seconds, 5 seconds, something to not overload it. The other thing is on the next one, I'm going to take some smaller transformers, but they're meant for 240. So we'll parallel the inputs on 240 to go off both phases in the barn, and then we'll series the outputs to give us the 480 to drive this, which I imagine when we kick this thing on, we're probably going to see the lights flicker. And that's probably because we really don't have enough grunt feeding that thing.
Right. Because we only got 17 amps of 480.
Right. That's the maximum we could do, and that's going to take a lot to do it. And that little supply over there is just not quite up to snuff for this kind of a load.
It's enough for the, what is it, a 1-horse motor?
Yeah, that's a 1-horse on there.
It's enough for the 1-horse motor there, but it's not enough for the 3-horse motor here with the contactors and the transformer and everything else that's here.
But I'll make another one, and I'll keep it really small and try to make sure that everything is drive-centric. So we will have a set of fuses, but we don't necessarily, well, we'll have an input contactor, but all that stuff will be buried back behind it and really small and tight package. So we don't have something big and huge hanging off the side of this in order to be able to run it.
So running a step up from 220 to 480 gives us a lot more amperage.
Yes, we can draw a lot more amperage, and we won't have the lag because we're trying to use basically a small cable feeding it, etc. We won't have that delay of power coming through, causing us our phase loss and all of that. Now, we could have done this with the cheater capacitor, the box that all of that does. But
so let me just to clarify, a cheater is one of those units you get to use 220 single phase to make 223, but it's not a true 3-phase. It cheats it. Right. Because it jumps the phases.
And you just have to look at it in terms of power. All 3 phases are going to supply a certain amount of power out of each phase.
Right.
You have 3 phases, you're running 5 amps. That's 15 amps going into the circuit. Right. Take that down to just 2 phases. You don't have that 3rd phase there. You're really only taking 5 amps here. Your motor is going to suffer for a lack of available power.
Because you only have 10 amps available to it, even though it's spreading it across 3 phases instead of a true 15 amps that it should have with true 3-phase.
Yes, it's total power. Right. And it's simple Ohm's law.
Yep. Okay.
So the problem that it causes is you're spinning that motor on only 1 phase. If you're going to get any real work out of it, you're going to be overloading that phase. It's heat, it's basically hard vibration, it's work, you're trying to do all of what the motor would normally do with 3 phases with only truly 1.
And what we're running into here with using a true 483 phase, even though we're stepping up from 110, because of the grunt to get all of this started, that probably wouldn't work anyway because you're cutting out 1/3 of your amperage.
Well, in this case, I think what's happening is it's our controller saying, I got a problem. Okay. I saw a phase drop. I saw low bus voltage. I saw some problem, because we're really starving that thing for the power that this needs in order to run.
Got it.
So what I'm trying here now is to take that directly to the motor. I'm using the wiring in here because it's convenient.
But we're bypassing all of the contactors.
So this load is always presented to that controller, and we're not suddenly trying to, that controller is just idling, making 480. We're not suddenly trying to throw that big motor on there and get it to spin. It's already connected, so now we're bringing it up slowly.
And part of what's going on is in the contactors, am I correct, there are coils that draw amperage, so it's got that hit of that as well as trying to start the motor.
Because this motor is presented to the top of these contactors, so now you're trying to call in that relay, you're trying to present this load to it, and the controller is probably just hiccuping because you're asking a lot of it right now, and it really wasn't meant to do that.
Right. So the next phase then, pardon the pun, is to go ahead and, since we have it wired to the motor, is to go ahead and fire the controller up and see if the motor spins. We did disconnect the pump for the spindle drive because we haven't checked that yet to see if the oil is even oily or if it's just a big pile of poo or goo or grease or whatever. So
okay, I have my 3 phases disconnected here, but they're also disconnected up here.
Right.
So those hanging there shouldn't be a problem. We've got some light insulation on our terminals here. They're separated, so that should be enough to run. We have everything. Yes, here, let's do.
So right now, just while he's turning it on, what's going on is he's got the 483 phase coming directly to the motor and bypassing everything else.
And in talking with the manufacturer on this motor, what I found out is the reason they did this way is you could get this model of lathe in 3, 5, or 7 horse. And it was simply a longer body to the motor. And this was the small one, and this one was likely meant to be a student model. So it's not the big grunty one you'd use in a factory. This is like a training lathe.
Right. It would kill you slower instead of...
All the capability, just not the power.
Right.
Okay.
Let's go ahead and fire it up.
Okay.
Let's see if it fires up. So he's got everything on here. We have the controller over there. He's going to turn on, and this should theoretically come up very slowly and build up to speed.
No real paper to burn in case anything happens.
We're good.
Okay, yeah, this is on. So now that presents the load to the drive. So we shouldn't have any kick of it coming in, no heavy current draw. It should just wind up slowly.
Yes, that has to be on because we're still running through the fuses in the...
Yeah, and I wanted to leave the fuses in here just to make sure we've got some protection.
Yep, so the switch is still active, but there's no voltage coming to it at the moment until he turns the controller up.
So...
Yep.
Watch your eyes. Here goes. Ooh, that sounds good. Oh, yeah, I can see it spinning.
Yep.
Cool. Ah, hang on.
So now he's going to test the motor.
Up. What I'm going to do is read the current on the phases.
Hold on a minute. I'm going to explain. It's coming up slowly because the controller's bringing it up slowly.
And there's 3.3 amps. 3 amps. 2.7, but we did finally quit winding up, so let me go back and read these. Yeah, 2.7, 2.8. Yeah, 2.8.
So the phases of the motor are all equal, no shorts, no lags in the motor, the motor's fine.
Now, I already read the motor to ground as an initial test to make sure everything was working right, and now we have 3 balanced phases, and we're up to speed, and we're running, while we aren't running full load on the motor, we're not doing any real work with it yet, but this motor is good. This was our big concern, is whether this motor was good, and now we know the motor runs. That'd be I talked to the manufacturer, that would be a $4,400 replacement because they would have to build one off their old prints, and that ain't cheap.
Or we would have to find something else and modify it to make it work.
Yeah. There, we just took the cover off, so
what we're currently doing is checking the oil because this is why we disconnected the pump. We were concerned that there might not be any oil for the fluid drive to drive the spindle, and we're correct, there's not. So we've got to look up what the oil is that goes in there. So I'll bring you over and let you take a peek in here. These things are fascinating. I was telling Chris before we went to lunch that the more we work on this, the more stuff comes back to me from way back in the day when I used to work on these pieces of equipment all the time. It's just I've been away from it for so long, remembering that these aren't just a mechanical drive, but that they're a fluid drive, and how they work and all that stuff is, it's...
And that's to save the engagement, disengagement, like a hydrostatic transmission.
Exactly.
I don't know what this particular action is, but from what I'm gathering, it's basically that. When you lift up on here, you're shifting. There's the valve spools right back here. I believe this is the line.
Yep.
Yeah, because your pump comes up into here, up into
Yes.
a channel here. That's coming out into this housing over here, and then you switch in here to bring it down to probably a cylinder somewhere.
Yep.
But yeah, you can see the action move.
It's just like an automatic transmission, except you're manually shifting the fluid.
So instead of actually trying to engage a gear, you're engaging a clutch that engages the rest of the drivetrain.
Correct. Yep. So we've got all of these hydraulic lines around in here to control the spindle and how it drives. All of that cool stuff. How she works.
Here's the pawl to stop this at a detent for every turn, and then the shaft comes through into the back here to give you your different gearings.
Yep.
In and out.
Different speeds on here is what all this is.
And I'm trying to wipe this down and keep this stuff away from getting into the top of this thing. That's why I was running the vacuum earlier, was trying to suck all this silliness away from here. Okay, what I wanted to point out is right here and right over here. Now this could very easily be paint that I may have bumped that cover when I was taking it off, and that may just be paint because it looks like it's got gray and black in it, and it comes off very easily. But this guy over here is definitely a chip, and there's a couple pieces of chip in here. Now this looks like a cutting, not... Yeah, that looks like it's something that's been cut with an edge, so that could be just swarf from the machine from years past. It's all nice and clean and it's oily, so it's been in there a while. But we need to keep an eye out for anything in here that might be a shaving. Anything that made it to the bottom should make it into the filter and into the screens that would be in there, but anything up here on the top... Yeah, there's another one right here.
Filter he's referring to is that one down there, which is basically the same filter as what's on the Oakland.
Here's another little shaving that was laying right on top of here. It's a good possibility this stuff might just end up getting knocked off and go down into the bottom and be trapped, but we should probably take a minute to make sure. I don't think we can run this with the lid off. I think it's going to make a high holy mess.
Well, let's find out what oil it is and see if we have something comparable,
Yeah.
and then we'll go from there.
Let me text one of the guys at our shop.
Okay.
He may be able to tell me right off the top of his head.
Okay, you do that, and I'll do the... I was finding some stuff that said maybe a 40 weight, but I'll research. You talk to him, and we'll come to a conclusion.
Okay.
So here we are. We went to get oil. It's $50 for 2 gallons of the P46 oil for this, and we decided I'm going to go to the farm tomorrow to get firewood anyway, so we'll just get some oil from my nephew because it's significantly cheaper. But here's what we got. We got our spot cleaned out here now. So the lathe is going to go up in there as far this way as we can to still allow us a good-sized doorway. Then that spot's going to be open for the Oakland to go back in tight to the wall as much as we can so that when we pull the engine apart and it's tied up, it's not being a problem. We got our whiteboard up now. And that's good. So all the trim and everything for the Challenger is in the back room now. And Chris has got the plan.
So this panel can come off. It's just a box behind here and a channel to go through for wiring. So I can disconnect all of this. This style of switch is very common. I can get one similar to that. Put them in here, and it's even a possibility. We're going to keep the e-stop because it's a necessity. I'll try to go with a big button, so just something you can slam with your hand.
There's all kinds of that stuff upstairs in that
Oh,
panel.
yeah, that's right. I brought a whole bunch of that stuff. We can drop that in here. We'll have a forward and reverse. And I'm thinking we might replace this panel and I could put an actual speed control. While this is great, you can get all your different speeds that you need. I'm thinking that having these changeable and then putting a dial here, we can dial it right into the speed you want.
Literally to any 1 RPM.
Yes. Yep. And speeds and feeds on a lathe are hyper important. It's the speed that you're cutting, the speed that you're rotating, and when I see our guys at the shop, and when you get that perfect speed, those things just curl and you get beautiful. That's how you get those beautiful finishes.
So what we're going to be doing is using another controller like is in there. It's actually the exact same model. And we're going to be using that completely to control the lathe, eliminating these relay blocks.
Yeah, probably.
Yep.
We might, I could bypass those, bypass all of this, but leave it here, use the fuses, use the disconnect.
Right.
Probably even use the, well, I'm not sure if we want to use the transformer. We can look at that later. But
if we're using two 220 transformers,
we'll have 480 anyway, and
right.
that will come in as 480. We could run some of it up here to run this, the on-off, the clunk in and out. But we don't need these contactors, but I'd like to keep them here because if this thing ever needs to get turned back over into something to run at a shop, that would be best, is having these, because that's the way it's designed to run.
Right.
What we'll do is take that new drive controller, put it on here, and run it directly to this motor. So when you run the controls up front, you're actually running the drive, and the drive handles the speed, the direction, the safety, the control. Everything is there in the drive. So when you bang a button on the front, you're telling the drive, go ahead and turn on. So there's nothing going clunk, bang, pulling in on the line. It's all just a smooth transition that the drive just did.
When he's talking about drive, he's talking about a unit like this, which electronically does what a lot of the mechanics do over there. So we use a drive here. We don't have the bridge port hooked up with the drive yet, but that's what's going to happen here also, is the controls on the mill will be, and then we'll use the remote feature on this to control the mill speed rather than using the stuff that's on the mill. So our plan, we've got to go get firewood tomorrow, we'll get the oil, and then we will get this loaded up with oil, make sure there's no leaks, make sure the hydraulics works for the spindle drive. We're quite sure it does because the pump was making all kinds of noise, but the spindle was driving when we first fired it up. Get the oil in there, make sure that's good, and then we're going to be on hold on this project until Chris gets the new 220 to 480 three-phase transformer done and controller, and then that should, well, we know it'll run the thing because it already does.
And we need to look at this motor sometime soon. We might just take 220 off the panel, see if this thing can actually run, see if it was just the inductive load tripping a fault over there. If this thing actually works, we may take that pump apart and clean it out. There might be a sump down there that's full of crud, but we can take a look at all of this tomorrow just for some, you know, when I get up in the morning, I can come out here.
He'll have that done probably before I get my eyes open. So yes, that's the plan. So we will pick up again tomorrow, and at the end of the day tomorrow, this will be in place. It will not be functioning as a lathe, but it will be ready for the next phase when Chris needs babysitting again and he comes up for another weekend. So we're going to make pizza and relax for the evening, and we'll see you tomorrow. We are back, day 2, after lunch. Got a load of firewood this morning. We have oil. So we're going to find out how much oil this thing takes. And we'll go from there. Once you get started, I'll pick it up so we have a little air burp in case there's not a vent. And we'll go from there. We're using a, can't remember what brand it was.
I thought you said it was a 30?
It's a 30 weight oil, but it was a something or another, 1,000 something. Okay.
Should be perfectly fine for what we're doing.
Yeah, I can't remember the brand. Like a Chevron 1000 LT or something like that. But it's a hydraulic fluid used in tractors, so it's in the scope of what's used in these. Do you want me to get a big funnel to hold up?
That might be better because I can't tip any further than that.
Turn the jug sideways, you'll turn further.
I'm going to try.
Yep.
I don't think it's pretty full, so.
Yep. Okay, let's get another funnel. Hold on.
Yeah. I will try to pour slowly. I will try to pour as slowly as I can.
Yeah. Sideways, you have more airspace, since you would tip better, but you're okay. Okay, well, our limitation is the small funnel down here, so if I can get it right over the hole. Steady.
Easy, careful.
Oh yeah, pouring also. You can probably pick it up a little bit. Now that I got it over the lower funnel hole, it's not building up. So why don't we check our sight glass and see where we're at?
Well, I don't think we're even on our sight glass yet. Huh. We got some in there.
Yep, we're about, what would you say, 3/16 from the line?
Yeah.
So probably another quart. I figured it was going to be less than a gallon.
As soon as we turn it on and get that pump turning,
Right.
then this is going to suck way down.
Right. It's going to suck.
We got to fill all those lines and
Yep.
pump. And
Although we know there was some in it because it was working when we first turned it on.
we did get a little burble.
Isn't this exciting, watching us pour oil?
We should do this on high speed.
Probably will be. Whoa. Oh, it's because I don't have that lower funnel picked up. So obviously there's not a crankcase vent in this thing. I'd say you're probably good.
Yep, right on the line.
Okay. So we'll find out. This is a 2.5 gallon jug. We've probably used 2 quarts, which was my prediction. So we'll see how much your prediction adds to the lines.
Yeah. So, yeah, we just need to run the motor.
Yep.
So let me turn on the drive.
You make sure this is in neutral to start.
That'd be a good idea.
Not that it matters.
Make sure.
We're good. Up is where we want to be. That should be going.
Oh, it's forward and reverse, so center would be.
Oh, gotcha. Yep. Okay.
Being able to make a drive that doesn't need to be plugged in.
It's not wireless power.
Oh, did I turn on the?
It's the furnace one.
Remote.
There she goes.
Yeah, we're good.
I suppose it's possible the screen on that is plugged. I never thought of that.
It might seem to come from up here.
I can see the oil level going up when we do that. Now the oil level went way over full. But you can tell it's circulating now.
Yeah.
No leaks?
No. The other possibility is we might be going the wrong way.
Oh, I didn't think of that.
Hang on, we can fix that.
You just do that in the drive?
Yeah, do that in the drive.
Go ahead, Chris. It's cavitated. It's got air in it.
Yeah. Yeah, we could have everything full air in there.
Yep. Let's that'll open her wide up. Shouldn't matter because that's not hooked up, but that was spinning the right way.
Yeah. And leave it up and just let it run for a while.
So we think what's happening is because it's been dry for so long that there's just tons of air in those hydraulic lines that run the spindle, and we've just had to wait for it to start burping. So we were just sitting here and all of a sudden it just went swuck, and we could hear the pump take off. So we're going to leave this run for a while now and just try to let it burp. And our oil level is definitely high. I'd like to speed it up a little bit, but we'd have to stop it to do it. So the way this works is you can turn this dial all you want while it's running, but the speed won't change until you stop it. Let it sit for 2 seconds. It's called jogging it and then re-engaging it. And we don't want to stop it right now. We want to just let it run. We did have the polarity reverse, so the motor was running backwards earlier, so we may have contributed a little more air in there because it would have cavitated, but didn't hurt it any. So
well, we also haven't checked that pump screen. We could be starving it. That
right.
could be our chatter as we're starving it because of the clogged up.
That could be. Yep. There's 2 pump screens in this. There's supposed to be one down here somewhere, and then there's a big screen in the back that looks like a canister filter. We're gonna let it run for a while, and we'll be back.
I'm getting a fair deal of crud out of this screw.
So we're running at about 500 RPM right now. Just trying to put it through its paces, burp the air out of it. Why don't you show them what it does when you change the speed, like go up to 600.
Okay, well here we're going to go from 491 to 650. It's going to still turn at the same speed until, wait for it, there. That's right, we can't go those higher speeds.
Right, okay, so 500 is about as far as we can go without blowing the controller, because the controller can't handle the
load.
That load.
Okay. Let me reset that. Hang on. Because that'll be a pretty heavy load.
Yeah, so what's happening is we didn't change the speed. We left it at 691, and we just started the motor that way.
There. Okay, now we're down at 98.
Okay.
So when I... There.
So if I'm going to use this until we get the new controller built, I just need to keep the speeds down.
Yeah. Which
is fine for what I'm going to do. I'm not going to be planning on micro polishing anything at 2,000 RPM. So.
And once I get the new transformers and drive made,
when we get that, yes.
We won't. What we were getting over there was a DC volt bus under.
Yep.
Which is basically it's taking too much current, lagging that bus down.
Right, because the 110 going into the transformer, is that controller fed by 110 also?
No, that's fed by all 480 volt power.
Okay, all right.
It's got a big capacitor on it, so you're not going to, a dip in power is not going to cause a dip in control.
Right. Yeah. Because it's just not enough horsepower for this big of a unit.
Right. So we've got a small cord on it. We're not really...
So when we get it up to the 220 with the 2 transformers, that won't be any problems. We'll run about, what do we figure, about 17 amps?
Yeah, which is about right because that's maximum grunt on those fuses. So. Yep.
But we also have to remember we have a secondary motor. We're going to be eliminating the contactors, so those aren't going to be drawing. But the secondary motor we still need to test here for the pump.
Well, just by the math, yeah, actually we'll be probably right about 14 amps with everything running all the way downhill, 300 mile an hour tailwind. The reason I offer that is the fuses are almost always rated at basically 1 1/4.
Okay.
1.25. So 14 amps, 1.25 is 17.5 amps.
That's the draw of the motor. That's not necessarily the draw of the whole unit.
No, that'd be the draw of the whole system.
Oh, it is. Okay. So that includes the transformer for the 220 to go down there.
Well, I don't know that yet because the original one was taking 480 to do that.
Okay. All right,
You got
well,
that
we're going to
there
let this
before
run for a while. We've got a little shuffling. We're going to get this over in position, but we got some wiring to change.
And that's only a, yeah.
It's a 110 or a 220?
That's a 220, but let me dig around in my basement. I think I remember somebody picking me up a three-phase third horse, and I think that's 240, 480 if I remember right.
That I know the guy that got it for you.
That might go right on here without having, we can take the transformer off, go back to the original wiring. All I'm going to
Does that
do...
make me an Indian giver?
all I'm going to do is bypass the contactors, use all the same internal wiring and fuses, just take the contactors right down. So you'll just have to make sure it's up and running before any of that can come
right,
out.
because you're not that way. It's not that load. Plus, that's sludge. That whole tank is full of sludge. So
that all needs to be cleaned out. The lines need to be taken apart, disassembled, and cleaned. But yeah, running this guy on here really seems to have knocked a bunch of crud out of that lead screw. And you can see all the schmutz in the brush. Yeah, keep our speed down. And let's just get some glasses on here. There's first chips. And it's cutting it. Here, let's do... okay. So now let's do an engage on the... Yeah, we're running there. Which way is this? I'm way too fast. I'm actually thread cutting. Let's correct that. Come on, you gonna walk in there for me? Oh, let's go way down here.
Yeah, you were on the highest speed, so. There you go.
Hang on, am I... Okay. Oh, I'm between... There we go.
There you go.
You gonna lock in there for me?
There you go. Still pretty fast.
Oh. No wonder.
He found some sheet metal.
Wondering why everything's feeling all greasy all of a sudden.
Nice curls. It's a pretty good sharp bit considering I just dug it out of the drawer off the other lathe.
Yeah. We're still moving really fast there.
Yeah, we just got to figure out that spindle speed stuff, but
I like how this has a pull,
yes,
where it's going to stay locked, and a push to do it, where you can let it up and it stops real quick. And yeah, you can really see the difference in surface finish. Back here we're still rough, and right there we're nice and almost mirror. I was having problems getting this thing to move, but there's a ramp to it. So
yep.
I didn't know that. Well, now I do. Now it makes it much easier to find one and get it to lock in place. And
well,
this is...
Just can't stop flipping knobs and moving levers. We're still learning a lot about this machine. it's bringing back a lot of memories for me from 30 years ago when I worked on this stuff.
We got all these chippy things
I know,
all over
we
the
got
place.
chippies everywhere. It's in its place now. We have room over here because the Oakland engine is going to be coming apart soon, so we'll be able to back the Oakland in over there, and that will leave a lot of nice space in here. I got a big pile of crap to clean up over there tomorrow, but we got a house project to do tonight yet, and then that'll be a weekend. It's been a lot of work.
Yeah. It's been a lot of moving.
Yeah, but...
and now my only problem is, see, normally when I come home with a Band-Aid, I can say, oh, it's just a flesh wound.
Yeah.
But now she's going to be able to see video evidence of me with a hole in my hand and bleeding all over the machine.
Yep. Well, you know. And I know, guys, you say wear gloves, but he was getting a piece of metal out of the rack, so it wasn't like we were doing anything that needed to wear gloves. So anyway, that's going to do it for this one. There'll be more coming on this when we'll be working on it, of course, but also when you get the new controller built and we get all that done, there'll be a lot more functionality going, and there's a lot more to do. But the basic machine does now work from this controller, and so we'll be able to use both lathes and the mill, and everything will be copacetic instead of so pathetic. So.
Yeah, and everything is nice and tight over here in the machine shop area where everything is usable from station to station.
Yep. So
and then you've got from this point on is now car.
Yeah, exactly. So the Oakland won't be there forever, but it'll be tied up for a month probably. So I really wanted to have all of this done before we got that torn apart. So anyway, that'll do it for this one. We'll catch you on the next one. And what they say around here, don't forget, because it's important.